I'm sorry, y'all. I never felt it's nothing more than the slope of. You spelled derivative wrong? It's just the slope of the tan line. That's all it is. It can be at a point, it can be an equation. So we haven't talked a lot about notation because really all we've been doing is this little number, slope of the tan line equals, and then we do our limit and whatever, right? But we have some special notation. If it's the derivative of, I'm going to say of f of x here. So a long time ago, there was a battle in calculus, and I can't remember. There was, do you remember who the two notations? Did y'all learn about that? It starts with an L. It's one was Newton, but the hold on, different notations that they use, and they were so instrumental in calculus and founding calculus that we interchangeably use both of their notations. So you'll see them used both throughout. You really didn't have to know who they were or anything like that. I was just giving you a little bit of trivia. But anyway, here's our notation, and some of them come from Newton, some of them come from Leibniz. I don't know how to say it. But this is the derivative of f with the little dash on it, one time. If you're describing it as y, if it's the derivative of y instead of f of x, we would just say y prime. It's not, I don't remember which one did which. I don't know. One of them did the y prime, and one of them did the dy dx, and I don't remember which one did what. It doesn't really matter, but this is the derivative of y with respect to x. Dy dx. Yeah. Dy dx. And we use both of them equally as much. There's not one that we use any more than the other. Df dx. These are all saying take the derivative of this with respect to x, and you'll understand what that means soon enough. You can also do d dx of f of x. That's the same thing if you think about like fractions. That's the derivative of f of x. I'm still with respect to x. All of those are used interchangeably. I just want you to understand what it is whenever you see that, you know what the notation means. This will become like second nature to you soon enough. All these are the same thing. And they're all perfectly acceptable. Use whichever one floats your boat. All right. So, remember, all of these are the derivative, which means that all of these are the slope of the tan line. Right? And we know how to find that. We've really been working at a specific point, but slope of the tan line is nothing more than IROC. So, the derivative of x is really just the limit as h approaches 0 of, not my clock, f of x plus h minus f of x over h. So I said all that gobbledygook just to let you know that it's really something you've already done at this point. To find at a specific point, I could plug my value in here. Like if I wanted to know what's the derivative or what's the instantaneous rate of change at 2, I could say, well, what's f prime of 2? And you would know that that is plugging in for a specific value. Okay, so let's do an example. This is number 4. I told y'all this was going to be easy today. It's what you've already done. Number 4 says use the definition of a derivative that says f prime of a equals the limit as h approaches 0 of f of a plus h minus f of a. Do you see why this one looks a little bit different? Does everybody understand where those values were, why that a is there like that? This is that specific value we were just talking about. So this is IROC at a point, and the point is A. Okay. It says to use that definition to find the derivative of the given function at the given value of A. So it's f of x equals x cubed plus x when A equals 0. You've already done this. This is IROC when x equals 0. So what I'm finding is the derivative at 0. Does that make sense? So plug it in. The limit as h goes to 0. And now it's a plug and chug into my formula. This is mostly going to be about interchanging this new notation. All right, let's see. We've got 0 plus h is just h. So I've got the limit. No, let me forget the limit. Y'all get in the habit of the correct notation as you go down. They're so funny about that. H cubed plus h minus, if I plug in 0, I just get 0. Y'all follow me there? So here's my equation. If I plug 0 plus h in here, right? 0 plus h cubed plus 0 plus h minus 0 plus h. No, yeah. Does that make sense? Yeah, I just didn't know if it was that. I thought it was. Oh, okay, okay. Now I can cancel. Still gives me what? Which if I plug in is 0. What did I do wrong? That's 1, you're right. Golly. So this is the limit as h goes to 0 of h squared plus 1, which is 1, not 0. When it cancels, right, it's 1h, not just h. So you got to hold that place there. Right. I'm not going to spend any more time on that because we spent a long time doing that. But I do want to show you a new, I'm hesitant to show it, but they've started intertwining it on multiple choice questions occasionally. But it's an alternative to the difference quotient. It can be used, if you're FRQ, you can use difference quotient or the alternative formula. Yeah, that's okay. This would be f prime of 0 equals 1. No, as long as you have it defined here equals and then you go down and you have it here, you can stop there. Yeah. So the alternate formula, I'm not a fan, but some students like it a lot better. To find the derivative at a certain point, this is our alternate. It only works at a specific point. It doesn't work if you want the general equation. So this has to be a value. It can't be x. So only when you're IROC at a certain point does this work. But if you have that, then you can do f of x minus f of a over x minus a. Oh, the limit. I forgot the limit. Ah! as x goes to a. Sorry. Clearly, you can tell I don't like this form. But it works. It works just the same. And to show you that it works, let's do one from your work. So 5 through 12 on your homework ask you to use the alternate formula to find the derivative. And they give it to you a little bit different. Sometimes they say find f prime of x. Sometimes they say find dy dx. Sometimes they say find d dx of the function. And so they give it to you in all kinds of different notation, but it's okay because we're doing the exact same thing every single time. Let's see. Let's do number 7. Use the alternate formula to find the derivative at a. So this time I'm doing the limit as x goes to 3. Remember, before I've been doing h to 0, right? Now I'm not talking about that difference between my x's. Now I'm doing a whole new formula. Then this is where I'm going to do f of x, which is just square root of x plus 1, minus f of a over x minus a. Yeah. Mm-hmm. You do, and that's fine. Okay, so we would if we could, but look at the denominator of that. It would be 0. So we're going to have to do all that manipulation like we've done before to get it to where I can plug in 3 for x. But you're exactly right. That's what I'm doing. A and x are different here. Oh, whenever you start, yes, they will. If you plugged it in, because it's that formula is the limit as x goes to a. So if you were to plug it in on the bottom is x minus a. So if you were to plug it in, you'd always get 0 on the bottom. This is f of x minus f. All right, so now we work on cleaning it up a little bit. And I have the limit as x goes to 3 of the square root of x plus 1 minus 2 plus 3 plus 1 is 4 over x minus 3. What in the world can I do to possibly get to where I can plug in? How? So you're almost there. So I could square the top, but I can't just square top and bottom because I'd be multiplying by something different top and bottom. I got to multiply by the same thing top and bottom. So let's think about what that might do for us. If I multiply by x minus 3 on the top and the bottom, on the bottom, even with these multiplied together, I'm going to end up with 0 times 0, and that's not going to get me where I want to go, right? How about, and this is hard to think about, but do y'all remember conjugates in Algebra 2? What if I multiply by the top, the conjugate of that top up there? Get rid of some of the radicals. I'd still have one on the bottom, but let's see what happens. So do square root of x plus 1 plus 2, but I have to do it on the top and bottom. I'm trying to manipulate this in some way where I'm not going to have 0 on the bottom. any type of way. So I'm hoping that if I do this and I get rid of those radicals in the top. Remember, my goal is to be able to factor something down somewhere. I see a linear factor down here. I don't know if this is going to help me or hinder me or what, but I'm just trying to do anything I can to maybe get that to cancel some way. I can't have an x minus 3 in the bottom. No matter what else is multiplied to it, I can't have an x minus 3 in the bottom because 3 minus 3 is always going to be 0. I got to get it to factor out. So how am I going to get it to factor out? So this is my first shot. I'm going to try this. At least I can eliminate the radicals up top by doing this, and maybe it'll factor some way. Are you following me? It's hard. These are hard. All right, so let's see. The limit. You see what I'm saying, though? We've already done this. It's technically done all of this type stuff. All right, let's multiply. Multiply radicals together. The radicals go away, yes? So I have x plus 1. 2 times the square root of x plus 1 and negative 2 times the square root of x plus 1 cancel out. That's the point of the conjugates, right? So I don't have to write those. If you want to write them and then mark them out, that's fine. Negative 2 times 2 is negative 2. Oh, gosh. I'm sitting here looking at y'all like, right? No. Lord have mercy. And on the bottom, x times the square root of x plus 1 plus 2x minus 3 times the square root of x plus 1 minus 6. And yeah. Oh, you know what? I didn't even need to do all that. Do you see why I didn't? Why didn't I? What happened up top? What does that simplify to? X minus 3? You see it? I just did all that for nothing because look, in the bottom it was x minus 3 times the square root of x plus 1 plus 2. What was my whole goal to start with? I need that x minus 3 gone. I know that that's frustrating for y'all, but I like you to see whenever I work through a problem, the places, what my thought process is and how I go through. And sometimes these things happen and you go through all that and you go, but wait, let me back up. So this step was unnecessary because I lost track of my goal, which was to cancel these out. Y'all following me? Gosh, I even did that on my notes over here. I did it again. The limit as x goes to 3, 1 over the square root. Now remember, I'm trying to get to the point where I can plug this 3 in. Can I plug this 3 in now? Yes, because this does not give me a 0 on the bottom anymore. So I end up with 1 over 2 plus 2, which is 4. So the derivative at 3 is 1/4. Does that make sense? See what we did? Which, if you do the slope at the IROC at a point or the derivative, yes, that's how you tell. The little prime. What? I plugged in 3 here, so the square root of 4 is 2. Oh, because I was trying to get rid of the radicals in top, hoping for a linear factor. And conjugates, when you multiply conjugates together, those radicals cancel out. Conjugates are whenever you just change the middle sign. So if you had like the square root of x minus 3. To get rid of the radical, you could multiply by the square root of x plus 3, and it would eliminate that radical. Which definition of a derivative do you like better? This one or depends on the problem. So either one works. Y'all want to do one more together? Some of them ask you for the other one. Just be able to, you need to be familiar enough to recognize it, because if you're on a multiple choice question, they could say which of these correctly represents the slope at the point blah. And they'll probably have difference quotient, the alternate form. You see what I'm saying? So you'd have to be able to recognize it. But FRQ, you're never forced into any one particular way. Yeah. Yeah. Find the equation of the tan line when x equals 3. This absolutely looks like what we already did. It was on our test. But now you have a new formula you could use if you want. If you want to. I told y'all, even if you have holes from chapter 1, it's okay, because we're just going to keep filling them. How many of you are using the alternate formula as you do this? Anybody? Are you? Good. You can use whichever one. I didn't specify. Just, you want to use it? Try it out. See how it works. No. I'm going to do it both ways as y'all work. So for the alternate, you just do the function minus, plug the value in, and then it's over x minus a. So you do the function minus. Well, here, if I plug 3 in, There's no H in the alternate. Oh, I came off to the side and did y of 3. What? 2x squared. I have dyslexia. I'm not kidding. I literally am not like, wait. I got 5 because I put 3x squared as opposite 2x. I'm fixing to do the other formula too. If you did the alternate formula, is that what you got? That's not what you got. Uh-oh, I might have made a mistake somewhere. Were y'all watching? Yep. 6. Did y'all get -1? Okay. Sorry. All right, let's do it the other way now. I prefer the other way myself. I'm still not knowing the problem because look what it asked me to do. But I'm doing this at 3. H goes to 0, f of 3 plus h. F of 3 over h. I guess it should be y of 3, but that's okay. I already found y of 3 and it's -16. So I get 2, 3 plus h squared minus 13, 3 plus, the alternate might have been easier on this one. Oh, I didn't even do minus -6. 9 plus 6h plus h squared minus 39 minus 13h plus 5 plus 16. Nope, I need to close this off. Nope, nope. This 2 is just going here. Gross. H goes to 0. I've got 18 plus 12h plus 2h squared. 21, -39. That should cancel with the 18. I'm going to go ahead and do that. Before you distribute, yeah. Oh, I gotcha. Yes. Are y'all following? Am I making any mistake? Have y'all put the 0 in there? I don't know why I didn't combine those before I get negative. Either way, it was a lot of work, right? Looks like the alternate might have been a little less, but it had that factoring in there too. Lots of places to make mistakes here. And I always make a careless mistake. I am the queen of careless mistakes because I start going so fast that I'm. All right, but that's not all it wanted me to do. That is simply the derivative at 3. So that's the slope. So I have my slope being -1. I already plugged in and found my point. I'm not going to double my work. 3 -16. So y plus 16 equals slope times x minus 3. So I end up with negative x minus 3 minus 16, whichever way you want to do it. I'm going to shut up and stop here because I think that y'all get the point.